This week on QDL, do you sometimes feel like you work in a cave? Well, in today's Tech Corner, we'll talk to some people who actually do work in a cave in Missouri. Find out more when we come back. Welcome back to QDL. QDL is your weekly look at who and what is making news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest, and today we have kind of a special Tech Corner for you. We'll be talking to the folks at Brunson Instrument Company, a manufacturer of stands, targets, and calibration products that support a wide range of 3D metrology instruments available today, including a lot of the instruments that you've seen on this show in the past. But here's the thing, Brunson does not have what you'd call a conventional facility. As you can see here, their factory is buried deep in a cave on the eastern edge of Kansas City, Missouri. And today we're going to find out all about this unique player in the metrology field and about their unique location. And that gentleman you see in the distance there is Keith Mangili at the entrance to the cave. Hi, Keith.
Hi, Dirk. Welcome to the cave. Come on in.
Yeah, thank you. I appreciate that. You know, I've wanted to see this facility for a long time. I've heard a lot about it, and you know, I don't think I've ever seen a factory in a cave. So why did Brunson move into a cave in the first place?
Well, Dirk, that's a great question, and I get asked it all the time. But rather than me give you the answer, I'd like to introduce you to Dighton Brunson.
Okay, well, so hi Dighton. Why the cave? What's the reasoning behind putting a factory underground?
Well, that's an interesting story. As you well know, in the use of metrology equipment, temperature variations and any vibration are your enemy, and the same is true for manufacturing metrology equipment. So my grandfather, A.N. Brunson, decided that a cave would be the best place to put his factory.
So it was precision manufacturing that inspired the move from the previous downtown facility. When was this?
This was he bought the property in the late 1940s, and we started mining in 1955, and we moved in 1960. And at the time, the company was making a full line of surveying equipment, everything for the land surveyor, and he was also into this new product line called optical tooling, which was a lot more precise than the surveying instruments that he had been making. When he did that, during the manufacturing process, they realized that the building downtown, which was like a normal 3-story factory at 14th and Walnut downtown in Kansas City, was vibrating every time a truck rolled by or a trolley car rolled by. This wasn't anything that you could feel in your feet. But it would disturb some of the manufacturing processes, and it would definitely disturb some of the calibration and adjustment processes that they were doing. They were having to wait until like 4 o'clock in the morning on Sunday morning to do some of the delicate operations that they needed to do. So he decided, you know, not one to be constrained by conventional thinking. He decided that he was going to put his factory in a cave.
The cave is located on the eastern edge of Kansas City?
Right. I don't know how he identified this land out here, but he bought about 10 acres, and in 1955 he started mining it out, and he caught a lot of flack. It was called Brunson's Folly because at the time there weren't any underground installations in Kansas City.
I understand the bankers weren't interested in financing Brunson's Folly, but your grandfather found a different way to pay for it, with limestone, right? Tell us about that.
It was sort of fortunate timing because right at that time the federal interstate freeways were being built, so they had a lot of requirement for limestone. He set up 2 rock crushers out in the parking lot, and he mined the limestone, crushed it to different grades of rock, sold it, bought more dynamite.
Your grandfather sounds like an interesting guy.
He was a very interesting guy. Fortunately, I got to work with him for a number of years. He was an extremely creative guy. There was always something going on in his head. He didn't have a lot of formal education, but he was extremely persistent if he had an idea about making something happen. You know, I mean, this cave, whoever thought of digging out literally a couple 100,000 tons of limestone to move a factory into, and he was the same with the design of his instruments and the rest of his products.
Well, speaking of those products, I know your grandfather was a respected inventor and he held a lot of patents, but his instruments really earned their place in history.
Right, my grandfather, it turned out, was just in the right place at the right time with the development of his optical tooling product line. There was quite a demand for it in the aerospace industry. And he was, right there in the middle of the 20th century when we were going from propeller-driven aircraft to jet aircraft and to NASA and the rockets and the moonshot. All of that was a fantastic application for his optical tooling product line.
So aside from addressing technical issues like vibration and climate that you mentioned earlier, I understand that the cave is also very efficient.
Yeah, it turns out that we were green before anybody knew what green was. In our cave, we have a space that's equivalent to a 10-story office building, and we heat and cool it with a very minor amount of equipment.
Thanks, Dighton. I think that's really just a fascinating story. A factory in a cave. Who knew, right? Thanks for sharing that with us.
Yeah, absolutely, Dirk. No problem. I think Keith is going to give you a tour of our cave, and you'll meet some of our people. We have a really great staff of people who are just obsessed with quality and precision. They really make me proud to be associated with them.
And now we're heading out to the cave's production facility. Is this a big factory, Keith?
Dirk, this cave is enormous. Hundreds of thousands of square feet. And if you allow me to, I'd like to give you a little tour to give you a better feeling.
So how do you organize the production process?
We break the cave up into cells. As you can see behind me, this is a cell called our optical tooling cell. It's the home of our legacy products. Quite honestly, the product line we cut our teeth on. And in that product line are things like jig transits, sight level, and optical scope.
Okay, so where are we going next?
Now we're going to move on. We're going to go to the measurement cell.
What are you making in that cell, Keith?
In measurement cell, we make the things that I like to call shiny stuff. And shiny stuff means SMR target holders in our INVAR product line, as well as one of our newest product launches called Canary.
Well, I like shiny stuff. Where are we off to next?
Stand cell is where we make our metrology stands. In this particular division of stand cell, we make what we call our rigid stands. We make our portable stands, which is our M series, and our Tetralock line of stands.
I see a big stand behind you. What's that all about?
You know what, Dirk? Back here is a 232 stand. It's made in our rigid product line, in our standard stand cell, but it truly is a little bit larger than common stands. It allows you to get your instrument at a higher level off the floor, which gives you a better visual vantage point.
Wow, what's in that big crate over there?
This just happens to be a base of a product called the 232 SP. We're getting ready to ship a couple of them out tomorrow, actually.
That's huge.
They're huge. They go from 10 feet to up to 34 feet.
So where's the upper portion of that stand?
Great question. We just happen to be assembling one in the pit. Follow me over here. This is the pit, and if you take a look down, you'll see the same base that you saw over in that crate, that it now has part of the up tube mounted to it. We'll continue on assembling the rest of this stand, getting all the up tube into place, inspecting it, make sure it's done properly, then we'll disassemble it, which will allow us to crate it up in crates like this, marry it with the crate of the base, put it on a truck, and ship it to our customer.
So hole in the ground and the hole in the ground. Got to say, this cave is pretty cool. What else you got for us, Keith?
Follow me over here, we'll go to the next spot. Well, Dirk, remember when we were at the other end of the cave, in the beginning of the measurement cell, this is down the tunnel quite a ways, and it is an area called serialized and certified. This happens to be Sandy's area. Hi Sandy, how are you today? Great. What Sandy does in here is she double checks all the target holders we make to make sure that they're within specification or certifiable. In my hand I have a pin nest, and then I also have an edge adapter. These are just two examples of the products that she works with all day long.
Thanks for the tour of the production facility, Keith. You know, that is actually pretty cool. And now we're going to pick up the tour at a later spot.
Welcome to our training facility. We use this room for many purposes. Mostly, however, it's for alignment training for our customers. At this point, I'd like to introduce you to Mark Sekulich, who will tell you all about Canary.
Thanks, Keith.
Okay, Mark, tell me something about Canary. It's a system that does a field test for a laser tracker.
Yeah, so Canary is a simple way for a laser tracker operator, user, or owner to check their tracker without having to send it back to the OEM for full CalCert.
So Canary tests a laser tracker in the field. How does that work?
Yeah, thanks, Dirk. Essentially what the Canary allows the operator to do is check their tracker at any time to make sure it's performing within acceptable parameters. It could be before an important measurement. It could be as part of their quality plan. But what it does allow you to have is the knowledge that your tracker is performing properly and provide you the peace of mind that your measurements are going to be the best they can be.
Compared to the typical two-phase test for laser trackers, the Canary process is more precise. Do I have that right?
Yeah, and historically what laser tracker operators have done is utilize a two-phase and length reference check utilizing perhaps something like a Brunson length reference bar. What we're able to do with the Canary, it takes that to a whole nother level. We're bringing it in for a near field full volumetric check. We're orienting the artifact in a variety of positions, and we're collecting data that is going to be output in a objective manner for you to analyze.
Who is the typical customer?
Our customers are a variety of disciplines: aerospace, military, defense, automotive, oil and gas, construction. Really anyone who owns a laser tracker benefits from Canary.
It's an interesting story how this product came about. Why don't you tell us about that?
Yeah, that's right, Dirk. What happened was Air Force Metcal came to NIST and said, you know, we need a way to consistently report data that we're collecting from trackers. Can you help us out? And so NIST evaluated the B89 standard and created an interim field check for laser tracker users that they could run on their laser tracker at any time to confirm that the tracker was performing as it's supposed to. They invited Brunson to participate with our knowledge of metrology and building hardware for metrology, and we collaborated with them to come up with what is now known as the Canary system.
So let's say I'm a tracker operator out on the factory floor. How long does it take to run the Canary check, and what's the process?
Well, the process takes about a half an hour or less to complete. Along the way, we'll orient the artifact in a variety of positions, and there'll be vertical, horizontal, raised horizontal, all of this also with the tracker being rotated at 90 degrees or straight forward. So we end up with between 30 and 40 points of data that we then analyze and create a output plot showing you how you performed against the MPE, which is the maximum permissible error.
So obviously the tracker operator is getting a data set to review.
Yeah, actually after we run our Canary evaluation, what's really important is seeing the output data, right? So what we'll do is we're going to process the data, and you're going to get a plot similar to the one here behind me, which shows you the measurement points against the maximum permissible error or MPE values.
So that's Canary. Thanks, Mark. Who do we have up next?
We've got Matt Settle coming up next. He's going to discuss measurement solutions.
Thanks, Mark. Hey, Dirk.
Hi, Matt. One of the things that Brunson is known for is measurement solutions. Describe for us what that is.
Yeah, well, our expertise is providing measurement solutions for large-scale industrial machinery. The way we like to say it is from submarines to space shuttles and a lot of industrial processes in between, we provide dimensional measurement control for the mechanical components in those systems.
So you're helping customers with critical measurements.
Yeah, we do. Just for an example, we had a local customer here. They were making automotive batteries, and they were installing a brand new line to make the lead plates that go inside those batteries. That line's about 200 feet long, and it takes a lot of components that are positioned very precisely to manufacture those plates. So we came in and helped provide the services to align those machines, typically within 5/1000ths of an inch or less.
5/1000ths, okay, that's pretty tight for sure. So you're working in all sorts of manufacturing operations. How do you adapt or work in those different situations?
Yeah, that's very true, Dirk. And when we go into all these different places, we do a couple things. First thing is we listen to our customers. We need to be sure we understand what problems they're having, because every place we go is different. There's no two projects that are alike. And so we want to be sure we understand what our customers are needing to have solved, and then with that conversation, we're able to put together a solution that works for them.
And I assume your customers are pretty diverse, a lot of different industries and processes?
Yeah, there's a lot of different industries that we go into. There's machinery that requires bore alignment. We have roller alignments for web processing equipment for things like steel and paper, printing, all kinds of converting processes for roller alignments. There's fixture alignment in aerospace and automotive, making sure that the points are in the right place when you're mounting up your different components that in the build that you're doing.
I assume you also work in power generation?
Yeah, there's traditional steam-powered power plants that have turbine generator combinations there, the rotating machinery. We'll do centerline work, bore alignments with that. And then in the hydro plants, that gets into a vertical orientation, and we provide similar types of alignments for those center lines as well.
So you're in the Brunson training classroom in the cave there. Who attends your classes and what are they learning?
Yeah, we have a lot of different people that come really from all over the country, all over the world, if you will. And this is one of the fundamental metrology courses for large-scale machinery. And you can learn what it means to make things straight, square, plumb, concentric. These are all geometries that are used in the measurement process for these larger machines. And this is a great place to get a foundation for that learning.
That's great, Matt. Thanks for talking to us. Appreciate it. So who's up next?
Well, we have Adam Warden, who's going to be talking about a new product we call Stasis.
Thanks, Matt. Hi, Dirk. How's it going?
Really good. I'm not in a cave, but kind of feels like one sometimes. So tell me about Brunson's new Stasis.
So Stasis is a positioning system that was developed specifically for the 3D scanning technology. What it allows us to do is move the scanner around either on wheels to reposition it, or also to just position it quickly in three-dimensional space from one shot and then to the next shot. And it's designed such that it has quite the large volume of space, so you can take high shots and low shots all from one position in a quick fashion.
So there's complete roll, pitch, and yaw motion on Stasis.
Yeah, so it has several degrees of freedoms, not just rotations about some of the major joints, but also up here where the scanner sits, it does have roll, pitch, and yaw axes that function just like a gimbal, to where the instrument is centered in the center of gravity to allow for a nice, balanced, smooth motion.
So what problem in the market were you trying to address? Why did you develop Stasis?
So as scanners have kind of flooded the market and emerged, we've noticed that there wasn't really a solution designed specifically for how they're being held and repositioned. So a lot of what has been traditionally used is products that were designed for studio photography. So we wanted to take the opportunity to actually develop a positioning system, a stand that was specific for scanners, their users, and the applications that they go through.
Okay, so Stasis just lets you get to the next shot faster. I get that. So it speeds you up, basically.
Yeah, that's exactly right, Dirk. So traditionally with the studio stands, you're moving in 1 degree of freedom at a time. So you're either traveling up or down, in or out, side to side, rotating. And then you're kind of just getting the scanner into a approximate position, to where then you have to go to the camera mount itself and adjust its degrees of freedoms and position the scanner to do the fine-tuning of its focus and field of view that you want to take. So what Stasis does is it allows us to go quickly from point A to point B in a three-dimensional straight line or a curve or whatever it is, so that you're not having to go 1 degree of freedom at a time. So you can quickly go from a shot on one side of the part, capture it, and then immediately swing all the way around to the other side of the shot in a matter of seconds to capture your next image.
For the engineers in our audience, how does Stasis carry the loads? Some cameras or scanners can be pretty heavy.
So mechanically, it's set up similar to what other robots in the industry are, to where basically we have rotational joints that are acting similar to cantilevered loads. And in order to balance each of those axes, we produce a counter torque. And we do that in Stasis by using some really high-powered gas springs. In order to balance a 35-pound load at the distances that we have from our axes, we're actually generating about 2,000 inch-pounds of torque per major joint.
So the mounting function on Stasis looks pretty nimble. How does that work?
Yeah, so we've given this the anatomical name of the hand. And essentially, it works very similar to like a gyro would, to where we have the center of gravity of the scanner is positioned about the center of the 3 different rotational axes that allow it to do the roll, pitch, and yaw functions.
So who's your market? Who do you see buying Stasis?
So where we see it being a really good fit from the scanner users we've talked to, the trade shows we've been to, is primarily in the reverse engineering facilities, R&D facilities, QC labs, places where you're taking different parts, different shots on a daily basis. That's where we see Stasis being a real benefit based on its unique ability to go from that point A to point B in a very quick, short time.
Thanks, Adam, for showing us the Stasis. And who do we have up next?
All right, thank you too, Dirk. And up next we have Mark Moret, and he is in charge of our engineering department.
Hi, Mark. What's going on at the Brunson Engineering Department?
Yeah, hi, Dirk. At Brunson, it's all about precision around here. We get into a wide variety of different projects that range anywhere from doing some minor modifications to existing product to even doing some more elaborate start-from-scratch design based on a new industry for a new product we want to develop, or even just working closely with customers to do something very specific to them. In all cases, our designs deal very much with precision. And as an engineer around here, maybe this is what makes us a little bit unique. And as design engineers, we can design things to very, very tight tolerances. But as a design engineer, you also want that tangible piece of how to know what those really tight tolerances mean. It's a great opportunity here at Brunson that we actually have manufacturing resources and we build the stuff out in the factory that we actually design in here. And it helps us close that loop on the engineer designing to really tight tolerances and then working with the machinist to get a good feel for what that actually means.
So this is the real world application of metrology, and I assume you're talking with your customers about the same degree of tight tolerances?
Yes, absolutely, Dirk. Yeah, customers come to us with specific requests about what they want to do, whether it's us building an accessory for their metrology solution or actually helping them develop a solution. One of the jobs that I have is to really try and iron out what are the requirements of what the product needs to do. And that isn't obvious at first, but it's part of the nature of doing R&D, is you take your best stab at doing the design, and then you go out and produce it and you test it and you see if you hit the mark.
And sometimes, as you said, a brand new product comes out of the process.
Oh, yes, Dirk, absolutely. And that's what we really like to do, is we like to solve customer problems out there. And it's great when we can solve a problem that really turns into a product that we then offer to the whole market.
What's an example of that?
Yes, I think that earlier you saw a little bit about the Canary project, Canary product. The Canary is something where NIST actually approached us, and it turned out that we did a partnership with NIST to develop this product. And it was a good utilization of their expertise along with our expertise. They were receiving requests from the field to do basically field checks of instruments in the field, specifically laser trackers, and there just wasn't something out on the market that would do a very comprehensive check. So they approached us and said, hey, they were willing to go off and write a process that would do a full comprehensive check on it, but they needed somebody to help do the mechanical design to match up with their process, and that's where we got involved. And we developed a very good mechanical system and also some software to go with it. And it's a great product out on the market today.
This whole time you've been standing next to some sort of stand, so I assume you want to tell me about it. Is that another example of what you were just talking about?
Yes, I'm glad you asked about this one, Dirk. We call this our Tetralock, and this originated very similar to the NIST story. Our sales guys and customers were requesting a new product that would be lighter weight but still hold the stability for metrology, so that you could put an arm on it or a tracker on it or other metrology instruments and still have stability.
I understand Brunson was just granted a patent on Tetralock. Congratulations. What was the innovation covered by the patent?
So in the design, there's some stops up in the leg, meaning that you open it up to a hard stop. We complete the triangle by these cross brace members that go across. You can see there's 2 in place right now. I'll bring the third one over. And we designed it for interference. The purpose of the interference is we want to pre-stress the legs. So as I lock this in place, I have a little ramp on the end of this that interfaces with the ball. And as I click it in place, you hear it snap in place. What happened was it just stressed the leg to wring out all of the play because of manufacturing tolerances that allows this thing to collapse. So now it comes down to the performance of the stand is truly based on the material performance, not the fact that it closes up.
We appreciate you sharing the engineering side of Brunson, Mark. Thanks a lot.
Sure, absolutely. Thank you, Dirk.
So there are a lot of fascinating companies working in the metrology field. I don't think many have quite as interesting history as Brunson Instrument Company. And we appreciate the opportunity to get to talk with Dighton Brunson and to learn all about this amazing cave facility and of course recognize the unique niche that Brunson occupies in metrology. That's it for today's show. As usual, if there is someone you would like to see on the show or some topic you would like us to cover, send those ideas to us at qdl@qualitydigest.com. Thanks for joining us today. Thanks to Brunson for inviting us in, and we will see you next week on QDL. So long.